All right, so in 3.6 we talked about a bunch of theorems having to do with perpendicular lines, okay? That if perpendicular lines form congruent adjacent angles, perpendicular lines form if two lines are perpendicular, they form four congruent angles. If the exterior sides of two adjacent angles are perpendicular, then the angles are complementary, okay? And then we talked about that if two lines are perpendicular to the same line, that they would be parallel. So in number 1, it says find the measure of angle 3. I'll zoom in on that picture. Okay, how do we find it? This involves a couple of things. Yep.
Two adjacent angles that
Linear pair.
Are complementary.
So these, you're saying these two?
Yeah.
These are the two you're talking about? Okay, those two would be complementary because that's a right angle, which means that the little angle that's not marked would be what? 18. And what does that mean for angle 3? It's also 18 because why? Vertical angles theorem, okay, if it asks me to justify it. Number 2 says, how do you know that A and B are parallel? How do I know A and B are parallel? Actually, you could do both. Okay, technically because they're right angle, I would say that these two lines are perpendicular to the same line. Okay, but you could also say that they equal 90 degrees, and if they both equal 90 degrees, then they're corresponding. That would just take an extra step. Okay, so two lines are perpendicular to the same line. And 3, find the distance between the two parallel lines. So we ended the day with this yesterday, okay? But if I picked a point, and so it appears as though I could use either one of these sets of points, but how do I know for sure? Find the slope. Good. So the slope of this line would be 0 minus 4 over 5 minus 0, negative 4/5. The slope of this line, negative 5 minus a negative 1, which becomes plus 1, 1 minus a negative 4, plus 4, negative 4/5. So I know that those two lines are parallel, and their slope would be negative 4/5, which means I'm looking for the slope of the perpendicular line to be what? What would be the slope of a line perpendicular to those lines? 5/4, right? Positive 5/4. So I could pick either line. Let's say I just pick this one. So I'd get negative 1 minus 4 over negative 4 minus 0. Negative 5 over negative 4, which is 5/4. So this is perpendicular. And then I can use the distance formula with these two. Square root of negative 4 minus 0 squared plus negative 1 minus 4 squared, negative 4 squared plus negative 5 squared, 16 plus 25, square root of 41. And without a calculator, it would stay just like that. Yep.
You wouldn't have to simplify that to 1 and 1/4.
No, you never want to put slope in a mixed number form. You always want to keep slope improper, as long as it can't be simplified. Like if it was 10/8, then you've got to simplify it. But if it's 5/4, then you keep it as 5/4. Fernando.
I got 45, but I didn't do that.
What'd you do?
From the same line, I just did the distance one. I just plugged it.
From which line? They said that it's already parallel. Do you need to find all the slopes? I didn't have to find this one. Once I found this one, I know the slope of one of the two parallel lines, but you do have to find this to make sure that it's perpendicular. If it's not perpendicular, then I couldn't use those 2 points. Does that make sense? So you have to show. So if this was not perpendicular to this, then I couldn't use these points. Maybe these were the two that were perpendicular, so maybe this line ended up being perpendicular, but not the other one, and that would tell you how to use those points. So you have to confirm that it's perpendicular in order to pick those points. Does that make sense? You can't just say it looks like it's perpendicular, okay? Was parallel lines, perpendicular lines, and skew lines. So you want to be able to determine the difference. If I gave you a diagram and asked you to find skew lines or parallel lines or perpendicular lines, that kind of thing, you would want to make sure that you would know the difference between each of those. So what do parallel and skew have in common? Or else? They're non-intersecting. What's their difference? Leah. Or else? Good. So parallel are coplanar, which means I can make a plane through them, and skew are non-coplanar. So if you could picture like a box. Okay, parallel segments would be any on the same side, like the top and the bottom of the front side. So if I had A, B, C, D, those would be parallel. AC would be parallel with BD, right? Left and right. Okay, if I had D, E, F, G, and go in order of the letters, okay? I can also make a parallel, or a plane from A, B to F, G. So those would also be parallel. You see that? Okay, and same thing from the back top to the bottom on the front. D, E to C, D can be a plane. Those would be parallel. Okay, skew means they're going to be non-coplanar and have to run in a different direction. That's how they would not make a plane. So what? Give me an example of what could be skew to AB. A, B, and EG, good. Anything else? E, D, F, yep. Anything else? CF, good. One more. DG, good. All of those would be skew. Understand? Okay, and then perpendicular, hopefully you know, right? They have to meet, and they have to be a right angle. So the corners of a box are all going to be perpendicular. In my opinion, the perpendicular one's the easy ones, right? Okay, and then we talked about all the special angles here. We talked about corresponding angles. We talked about alternate interior. We talked about alternate exterior. And we talked about consecutive interior or same side interior. So these lines did not have to be parallel yet. We don't know anything about the relationship other than they are these things. So corresponding would be 1 and what? 1 and 5. 2 and 6. 3 and 4 and 8. Okay, alternate interior. 3 and what? 6. Good. Alternate 4 and 5. Alternate exterior. 1 and 8. 2 and 7. Consecutive interior. 3 and 5. 4 and 6. Okay, so I could give you a pair, and you could literally just be telling me that they are this kind of angle. Okay, Lourdes.
Are those angles like different if the two lines that aren't the transversal meet and form a triangle?
So if these go like this, is this what you mean?
Yeah, in the diagram.
Okay, this is still your transversal. So the line that connects them is still the transversal. I could have an additional transversal. So you had a diagram that maybe looks something like this, right? And you've got a bunch of angle. 1, 2, 3, 4, 5. Oops, daisy. Put 5 where 1 is. 5, 6, 7, 8. God bless you. 9, 10, 11, 12. My advice on that is cover up the part you don't need. So either literally take your hand and cover it up, because there's two ways that you can connect these. You could say that this line is the transversal and the white and the blue are the lines that I'm comparing. So 2 would correspond to 6, 3 to 8, 1 to 5, 4 to 7, right? You could look at it that way. Or I could say this is the white is the transversal. And so 1 corresponds to 10, 2 to 11, 9 to 12, and 9 to 4 and 3 to 12. Okay? And then I could even go the other way and say that this is my transversal. So when you have a diagram like that, my biggest piece of advice is cover up what you don't need. Turn your paper. Make sure you can look at it the right way. It's a good thing about that stuff, right? You can turn them. I'll leave colored pencils out. If you want to color code. Do whatever you need to do so that you can see that diagram, okay? It's not going to be that tricky this time. I think it was trickier on the quiz than it is on the test. Okay, also remember vertical angles, linear pair, all that sort of stuff, okay? Because I could have said, what's the relationship between, on the bottom diagram, what's the relationship between 6 and 7? What's that? Vertical angles, okay? 5 and 6, linear pair. So all of those things are still part of the mix of stuff that you need to know. Okay, then we got to 3-2. And we said if the lines are parallel, then So if the lines are parallel, corresponding angles are what? Alternate interior angles are. Alternate exterior are. And consecutive interior. So these three are the theorems. Like if you wanted to name them, it would be alternate interior angles theorem, alternate exterior angles theorem, consecutive interior angles theorem. And this one is the postulate. Okay, corresponding angles postulate. But again, if you don't remember the name, just write it out. If the lines are parallel, then corresponding angles are congruent. If the lines are parallel, alternate exterior angles are congruent. So you might see a diagram that says which of these are congruent, or which of the angles would be congruent to angle 1 and why, that kind of thing. You can also use these in your proof. So you'll see these in more than one way. We got to 3.3, which was the converse to everything we had already talked about. So if alternate interior, actually let me go in the same order. So if corresponding angles are congruent, if alternate interior angles are congruent, if alternate exterior angles are congruent, and if consecutive interior angles are supplementary, then what? Good. So these all have the same name except they have the word converse at the end. So it's corresponding angles, postulate, converse. Alternate interior angles, theorem, converse. Alternate exterior angles, theorem, converse. And consecutive interior angles, converse. So if you are trying to prove the angles are congruent or the angles are supplementary, that's the irregular one. If you're trying to prove the lines are parallel, that's the converse. Does that make sense? Okay. So you'll see these again in a couple of ways. One is if you're given this information, what lines are parallel and why, or it would say, you know, what values of x and y would make the lines parallel, that kind of thing, or you'll use this in your proof. Okay, so you'll see it in a couple different ways. In addition to these four, we also talked about the transitive property for parallel. So it was like transitive. It's a V. I don't even know the exact name of it. Parallel. I think it was the transitive property for parallel. Okay, which basically says that if, let me find the exact name. Transitive property of parallel lines. Which basically says that if two lines are parallel to the same line, that they are also parallel, okay? So that's 5 ways to prove lines are parallel, and then we learn the 6th way later, which is what? How else do you know that lines are parallel? Yeah. Perpendicular, good. If two coplanar lines are perpendicular to the same line. Okay, so there's 6 total ways to prove that lines are parallel. So if somewhere in a proof it says prove line A is parallel to B, then you know you have 6 ways to figure it out, and look at your proof and figure out what information do you have that's going to help you in one of those 6 ways. If there's a right angle mark somewhere, then work the the perpendicular one, and see if it works. If you've got 3 lines that are parallel, then use the transitive property. If you've got alternate interior angles, then use that one. So you've got to basically look at what you're trying to do and figure out from there which of these 6 ways is going to get you there. Reagan?
Would you use converse?
That's if you're proving the lines are, if you're proving the angles are congruent. No, if you're proving the lines are parallel. All the ones we just talked about, all of these are converse. Right? All 6 ways are converse. So if the goal is to prove that the lines are parallel, you're using the converse. If you're trying to prove that the angles are congruent or same side interior, or supplementary, then it's the original theorems or postulates.
Oh, that makes sense.
So you've got to figure out what you're trying to prove. Remember, what did we learn first? We learned if they're parallel, then the angles are congruent or supplementary. Then we learned if those angles have that relationship, then the lines are parallel. So we learned the original before we learned the converse. Okay, then we went to 3.4, sorry. And this is where, hopefully, it began a little bit of review from algebra, right? This was your slopes. So we talked about how to find slope given a point. So y2 minus y1 over x2 minus x1. How to find slope from a graph. So we count rise over run. Okay, how to figure out what is steeper, okay? How do you know if one line is steeper than the other than looking at it? What's true about the slopes? The bigger the slope, the what? The steeper the line. Does that make sense? Higher the slope, the steeper the line. Think about your treadmill. The higher that number goes, the steeper your climb. So if I had two slopes and one was 3 over 2 and one was 10 over 3, which of these has steeper slope? Which one? 10 over 3, right? If you can't, like, if you can put that into mixed number form, right? That's 1.5, and that's 3 1/3. Which is bigger is the 3 1/3. Okay. So the bigger the slope, the steeper the line. Okay, we also talked about parallel lines and perpendicular lines. So what's the relationship of the slopes of parallel lines? Same slope. And what's the relationship of the perpendicular lines? Opposite reciprocal. So opposite sign and flipped fraction. Okay, then we did 3/6, which was now graphing all those lines. So you either found the equation of the line from a graph, or you found an equation of the line from 2 points or from a point and slope, right? So we started with y equals mx plus b, which is the slope-intercept form of a line. This is 3/5. Sorry, this is 3/5. So if you were given m is 2 and b is -3, super easy question, just plug them in, right? Y equals 2x minus 3. If you were given, let's say, 2 points, 2, -1, or actually let's do point and slope first. So if I gave you point and slope, then you would plug it into what? What's that formula called? Which is y minus y1 equals m times x minus x1. God bless you. So I do y minus a -1, which becomes +1, equals 1/2 x minus 2. Y plus 1 equals 1/2 x minus 1. Subtract the 1. Y equals 1/2 x minus 2. Okay, so first we were given the slope and the y-intercept, then we were given the slope and the point. The third kind is if you were given 2 points. So what do you have to do here? How do you find slope, because we need slope in a point or we need slope in y-intercept. We don't have the y-intercept, and we don't have slope, but we do have 2 points, right? So I would first find the slope, 4 minus a negative 1, 3 minus 2, and I get 5 over 1. And then I would use that slope with either point and plug it into point slope. Okay, then I gave you if a point like passes through (1, -7) and is parallel to 2x plus 4y equals 10. How do I do that?
You would solve for the y, and so you can get this slope, and then
So if it's parallel, I don't need to flip it, right?
like you need to flip it so when you put it into point, when you flip it,
It's not perpendicular, it's parallel. Right. So isolate the y on the second one, right? So I'd get 4y equals -2x plus 10. Divide by 4. So I get -2 over 4x plus 10 over 4. All I'm worried about is the slope. -2/4 is the same thing as what? -1/2. And then because it's parallel, use this slope, this point, and plug it into point slope just like I did that last example. If that entire thing was the same, but it said perpendicular, now what slope do I use? +2. Flip it and negate it. And then use that in the point, okay? Remember, there's a shortcut if it's in standard form, okay? So if you remember it, use it. If you don't freak out, okay? But -a over b would be -2 over 4, which gets you your slope a little bit faster. But if you don't remember it, then just go off of your regular isolate the y. Any questions on those? Okay, so remember that if it said the slope was undefined, it'd be what kind of line? Vertical, which is a x or y equals? X equals, okay? Those you can't plug in, right? If the slope was 0, you can actually plug it in. It would cancel out the x and you'd get your equation y equals whatever the number is. But the vertical ones you cannot plug in. Any other questions on 3.5? Okay, and then 3.6 is all of the day with. So 3.6 is all the theorems about perpendicular line. Okay, which you'll probably either use in a diagram, like if there's a perpendicular angle, could you give the other angle? If you've got where they're complementary, something like this. So if you had a right angle here and this was 40 degrees, could you tell me what x was? That kind of thing. Or you'll use the information in your proofs, okay? Like if you have, if you're trying to prove lines are parallel and they're both perpendicular to the same line, then you can use your perpendicular theorem that said that if two lines are perpendicular to the same line, that they would be parallel. So, not bad, we actually got through most of it. Okay, so any questions overall on it? Again, your chapter review, I'm going to publish right this second. So you'll see there's lots of practice if you need it. Don't overwhelm yourself, but do what you need to. So I did the review from the book, and I'll post the solutions there after the evens. And then the test from the book, same thing. And then there's 2 online quizzes, one you can take with your iPad, one you need a computer from, but they're both proof practice. And then one it's a worksheet with extra proof practice. So do what you need. Yeah, I'll be either in